Let's discuss the question number 12 from test series 4. This is from heat transfer. Okay, so cavity, equilateral cavity or a duct is given, which is shown here. Okay, which has three surfaces, 1, 2, 3, all of the same length. And now there are like four statements given as four options, and what is asked is which of these options are correct. And this is all about shape factors. Okay, so this is all about shape factors. So let's first see what is a shape factor. Fij. Okay, so shape factor Fij means the amount of heat or amount of energy, you can say, radiated by surface I that strikes surface J. So it's like surface I can emit any amount of heat, but how much of that strikes surface J? So that ratio is basically written. I mean that fraction of heat. That fraction, I should say, the fraction of heat which is radiated by surface I that strikes surface A, so that is called as shape factors. Okay, so it's basically that fraction. Okay, so surface 1, so what may happen is, suppose surface 1 is emitting heat, some of heat may strike it back. That can happen only when it is a concave, but for flat it will not happen. But in general, whatever heat that is emitted by surface 1, it can strike it back, or it can strike 2, or it can strike 3, and 2 and 3 basically enclosed. I mean 1, 2, 3 are enclosed. So I can use the summation rule first for each of the surface. Okay, so for surface 1 I can write F11 plus F12 plus F13. So what it means is the amount of heat that is emitted by 1 that strikes 1 plus that strikes 2 plus that strikes 3 has to be 1, because there are no other surfaces. This is all enclosed. Okay, now similarly for surface 2 the same thing applies. So it will be 2-1 plus 2-2 plus 2-3 is equal to 1. And similarly for surface 3 it is F31 plus F32 plus F33 is equal to 1. Okay, so now clearly one thing we can see is that because as these are flat surfaces, they are not concave. So concave means whatever heat that is emitting, it may strike it back. Okay, because whatever heat it may strike 1 also. So but that doesn't happen here. Okay, because these are all flat. This is flat versus concave. So flat means it just emits in all the directions. Okay, so as these are flat, so the F11 is 0, F22 will be 0, and F33 will be 0. Okay, and also because it's an equilateral triangle, so because of the symmetry, one can say that F12 has to be equal to F13, because with respect to 1, 2 and 3 are identical, and because the length is same and the angle which it is inclined with 1 is also same, 60 degrees, and the length of 2 and 3 is same. So that happens only pure because of symmetry. So F12 is F13. Similarly F21 will be F23, and with respect to 2, 1 and 3 are same. With respect to 3, 1 and 2 are same. So F31 is equal to F32. Okay, so let me use all this. I mean this. Let's say this is one set of equation. This is 2 and this is 3. So let me use this particular thing in the first equation. So as we know, F11 is 0 and F12 and F13 are equal. So 2 times F1. So this I am basically substituting in basically this equation. So I'll get 2F12 is equal to 1 and F12 is 0.5. So F12 is 0.5, so F13 is 0.5. So this is one thing. Similarly, when I use the second this symmetry equation in the second summation rule equation, with the help of that F22 is 0, I'll get that F21 is equal to F23 is equal to 0.5. Similarly, when I use the third equation in the third symmetry equation in the third equation, what I'll get is F31 is equal to F32 is equal to 0.5. So looking at whatever I got, looking at that, so all the Shea factors, the mutual Shea factors are 0.5. That happens in D. So the answer is D. The option is D. Thank you.